In this video, we will do a harder conditional probability example that involves a table of values. So the example says, suppose 70% of first-year students, 65% of second years, 50% of third years, and 25% of 4+ year students support having a football team at SCU. The table below lists some probabilities. So by 4+ year, I mean students who are either in their 4th year, or in certain cases, there might be students in their 5th or 6th year. Okay, so this table lists some probabilities, so depending on what year they're in. 1st year, 2nd year, 3rd, 4th, and then there's one row for joint 5th and 6th. And then it's broken up based off of, in this case, whether they went to public high school or whether they went to a private high school. And then the question says, a randomly selected student supports having a football team. What is the probability? And then this should say she is in year 4 or higher. Alrighty. So these columns here are a little bit of like unnecessary information. What I ultimately need to know is like what percentage of people are first years total, what percentage of people are second years, and so on. And I can get that by summing the values in each row. So if I add up 0.21 to 0.04, we get 0.25. So I'm going to start to just keep track of the sums, because the sums will tell me, well, what's the probability that a randomly selected person, for example, is a first year. So it's a 0.25 probability we just found out. And then from the next row, the sum is 0.28. From the third row, it's 0.24. From the fourth row, it's 0.18. And then from the last row, it is 0.05. So a lot smaller in the last row. And that's because usually there aren't quite as many 5th and 6th year students as there are in any of the other years. Alrighty. So another thing to keep in mind is the question talks about the probability that this person is in year 4 or higher. And that is multiple rows of this table. And even in terms of what's given in the problem, it mentions that 25% of year 4+ students. So that is talking about both the 4th year students as well as the 5th and 6th year students. These are considered year 4+. So we're going to be looking at those values cumulatively when we form our tree diagram. Alrighty, so let's label some of our events. So I'm going to let F be the event that a person wants football. And let's let F complement be the event that a person doesn't want football. Doesn't want a football team. So we are trying to find the probability. And it's a conditional probability because it tells us that this student supports having a football team. So it's going to be given that they want football. And it's the probability that this person is in year 4 or higher. So I'm just going to write 4+ year, given that they want football. Or using our symbols, this is probability that I can write just 4+, given and want football is F. So we are after this. Alrighty, so let's zoom it out a little bit so I can see the numbers and start drawing a tree diagram. So I'm going to draw a portion for where we begin. And then there's 2 stages that I'm going to consider. I'm going to consider what year a person is in, and the question of do they support having a football team or not. And then we could write down the outcome and the probability. All right, so for the year, there are 4 choices actually. They could be in the 1st year, they could be in their 2nd year, they could be in their 3rd year, or 4th year. So there's going to be a lot of branches to this tree diagram. That's okay. We can handle that. And then from each of those, either they will want football, which is F, or not support having a football team, which is F complement. So we'll draw that from each of these, F and F complement. Here as well, F and F complement, even from the fourth. Whoops, this last one I should have actually just written 4 plus, because I'm considering year 4 and higher cumulatively. Okay, so this one as well, I'm going to draw 2F and F complement. Now let's write the outcomes. So I'm going to write this as 1F complement, 2F complement, 3F complement, 4F. Oh, sorry, this should be 4 plus F. 4 plus F. And then 4 plus F complement. Okay, so now we're at the position where we label some probabilities. So from the table, we see that 0.25, that's the probability that someone is going to be a first year. 0.28 is for them being a second year. For a third year, it is going to be 0.24. And then for a fourth year, we have to add two values. We got to add the 0.18 plus the 0.05 together. And if we do that, that'll give us 0.23. Okay, so pretty close in those values. And that typically makes sense. Most schools want to have roughly the same number of students in each year. Okay, so then what did the problem tell us earlier about what percentages supported having a football team within each class? So 70% of first years supported a football team. So for under the first branch, I'm going to write 0.7 going to F. And let's see, for second years, it was 65%. So for second going to F is going to be 0.65. Okay, and then for third years, 50% supported it. So I'm going to write a 0.5 here. And then finally, for year 4 plus, it was 25% of them. So let's write a 0.25 here. And at this point, I think I've taken away all the numbers that I need. So I'm going to zoom in and start to fill in the rest. So this will be 0.3, this will be 0.35, this will be 0.5, and this last one is 0.75. Now I can do some multiplication. So let's see, we get 0.25 times 0.7, and then 0.25 times 0.3, 0.28 times 0.65, 0.28 times 0.35, 0.24. Sorry, I'm drifting that one too far low. 0.24 times 0.5, and then it's the same thing again, 0.24 times 0.5. Two more to go. 0.23 times 0.25, 0.23 times 0.75, and let's multiply these now. So altogether, we're going to have 8 of these values. All right, so the first one is 0.175, and then we get 0.075. Third one is 0.182. Fourth one is 0.098. Then we get 0.12, 0.12, 0.0575, and then finally 0.1725. Phew, okay. So we are finally ready for the probability that a student is in year 4 or higher, given that they support having a football team. So using our formula for conditional probability, we put the probability that they are in year 4 or higher, intersection, which means the word and, the other event, F. So we need the probability that they are in year 4 or higher and that they support a football team on the top. On the bottom is the probability of F. Whatever we're given that goes on the bottom. Alrighty, so let's highlight the top. So what what outcomes refer to that in the table? Well, this is it, year 4 plus, and they support a football team. So let's highlight that. And so the numerator is 0.0575. Let's highlight that. And then all over the denominator, probability that they support a football team, that's going to be several outcomes. Here's one, here's a second one, here's a third one, here's a fourth one. So I'm going to highlight all these numbers as well. So adding those up, we get 0.175 plus 0.182 plus 0.12 plus 0.0575. If I were to add those values in the denominator, we get 0.5345 for that denominator. Okay. And finally, if we evaluate this using a calculator, it is about 0.108 after I round it to 3 decimal places. And that is our answer. So in terms of our goals for this section, we finished our second goal, which was, over the last few videos, we've solved a number of these Bayes probability examples using tree diagrams. And as we saw, we did some more challenging examples than we've seen before. For example, we've looked at a situation in this video where we had to combine multiple values in a table to get what we needed. So the values in the tree diagram weren't immediately given to us. We had to do a little bit of computation first. In one of our other videos, we had an asymmetric tree diagram. We've also seen situations where we have multiple branches, so more than just 2 at each stage. Like in this video, we saw 4 in one of the stages.